everyone. So in our last lecture we have learned to generate the anechoic with the help of Cartosat1 stereo pair data and the DEM on the NV software. Today we will use that anechoic on the GIS platform, and we will learn that how we can extract information with the help of this 3D image, that is anechoic, and we can map different kind of geomorphological features, and we can digitize that those geomorphological feature, and we can prepare a tectono-geomorphological map. So here you can see I have imported the anechoic on the GIS platform, and first thing that when you are importing your map, so here on the layer panel you can see that this map is right now is not geographically corrected, or it is not georeferenced. So you can right click or you can go to the properties, and when you will check your information, here you can see the CRS, that is the coordinate reference system, this is empty. So this map is right now don't know the exact location on the globe. So first thing, you have to georeference your anechoic, and in one of our lab we have explained that how you can georeference different kind of satellite images. So today we first you have to georeference your anechoic. So to georeference your map, you have to go to the raster panel, and there you will see the georeferencer, and with the help of this georeferencer you would be able to georeference your anechoic. So to georeference your anechoic, first you have to identify some GCPs, that is the ground control point, and with the help of the base map on the WMS plugin, so you would be able to georeference your map. So you have to identify the GCPs. So to identify or extract information or the geomorphological features, you have to use the 3D glasses. So this is a 3D glasses. This is a 3D glass. So you can see this glass is of two color. First is the red and another is the cyan color. So as I explained during the anechoic generation lab, that when you are generating the 3D maps with the help of stereo pair image, so your RGB bands has been converting into two band, that is your red and cyan. So your red color is assigning a single red band, and another your blue and green band has been assigning a single band, that is a cyan color. So to extract information you would be required to the red and cyan color. So you can see over here that this glass is of two color, first is red and another is cyan color. So with the help of this glass you can extract information, or you can view your anechoic in the 3D domain. So first you have to wear this glass, and with the help of this glass you can see the 3D features on your anechoic. So here you have to first import your map. So here you can see that here I have imported the map, that is the anechoic, and with the help of this 3D glass you can see your map in 3 dimension. If you have to you can easily buy this type of glasses for from any kind of online retail platforms. So you will get this glasses at very cheap cost, around 100 to 200 rupees. So you can buy these glasses from there, and you can use this glass to extract the or view your map in 3 dimension. So if you have the glass, or you have the this 3D glass, so you can see over here, you can pause your video, or you can see with the with using this glass. So you would be seeing this anechoic in 3 dimensions. So here these are the all hilly terrains. So these are the Shivalik hills of the Himalayan foothill zone. Here you can see this is the river area, and this area is the foothill of the Himalaya, that is the Indo-Gangetic plain. So this area you can see this is the flat area. This is the all the alluvial cover of the Himalayan foothills, and this sediment is being brought here by the Himalayan rivers. For example, for this reason this sediment has been deposited by this river, these rivers. So you would be able to see the your structures or your geomorphological feature in the 3 dimension with the help of this glass. So first we will georeference this map to assign the coordinate reference system, and then we will map the different kind of geomorphological features with the help of this anacliffe. So to georeference, you have to first identify some common some features that you would be easily identify on your anacliffe as well as your base map. So first you have to open the base map on your QGIS. To open your base map, you have to just go to the quick map service, and you can choose any of the Google service maps or any other maps. Here you can see different maps are available. So I would choose the Google satellite image, and you simply click on the zoom to the layer. Here you would be see that your map is opened. So first you have to identify your area. For example, this map is from the the Haldwani region. So first you have to identify this region on your base map, and so this is your Haldwani region, or you can simply use your Google Train images that will enable all the labeling part. For this Google satellite image, you cannot see the labeling part, but I know that this map is from this region only. So you have to first identify some common point that you can use as your GCPs. So first you have to identify 4 to 5 GCPs to georeference your map. So I will mark the GCP. To mark the GCP, you enable this add point, and you click over here, and a window will pop up, and from the map canvas view you simply go to that location which you have choose for your ground control point. So here you can see the first point has been marked, and the another point I would mark from somewhere here. You have to keep in mind that the point which you are marking on your to georeference the anacliffe or any kind of satellite images. So you have to distribute the point all over your image, so that your georeferencing is correctly generated. If you are clustering your point at particular place or particular location, so that would ultimately create some kind of error with your georeference map. So you have to best way is that you can choose 4 point from 4 corner of your map, and if you add some more point, you can choose point from the center portion of your map. So now I will mark my third point. So from this bottom right corner of the map, so here I am able to identify some houses. So I first identify this place on the base map. So here you can see a bridge. So I would mark my third GCP over this bridge. So you can choose this point as your GCP. So these all points I have already discussed in earlier labs. So how you can choose your GCPs, or what kind of features you should choose while selecting your GCPs. These all things I have already explained in our georeferencing lab. So you can follow that lab, or you can use those instruction while choosing your GCPs. So here you can see I have marked 4 point, but I would mark another point. So the number of point if you are marking, that will ultimately enhance your georeferencing, or that will give the more accuracy to your georeference map. So I have marked the 5 point, but I can mark another point somewhere in this location, because this area is left out. I have not marked any point on this area. So I would mark another point here. So first you have to identify the location where you can mark your GCP. to choose your GCP, first you have to identify the location. To identify the location, the simple way is that you can simply trace the roads or the any kind of natural features, that would be your river or your forest area, that kind of things you can trace, or that would help you to locate your area where you want to add the GCP. So here you can see that I have marked 6 points. So all those points you can see over the GCP table. So this table you can enable from the view setting, or here you would be able to see all the information regarding your ground control point, the residual, that is the your error associated with the individual ground control point. So that you would see over here on the residual panel. Once you have selected the triangulation or resampling technique, then you would be able to see your residual errors for all the individual point, as well as the cumulative error that is associated throughout your image. So these error are basically the errors you which is associated with the GCP. So try to select the point which you can easily identify both on your target image, that in this case is the anacliffe, and the on your base image. So if you are not selecting the point very accurately, so that would be include the error in terms of your pixel values, or that you can see over on the residual panels. So now I will select the transformation method or the resampling method. So I will start from the linear or the resampling method, the nearest neighbor, and the target coordinate reference system would be your WGS 84, because this Cartosat 1 image is acquired data on the WGS 84 reference system. So here you can see by default your output file has been given. You say click on the save GCP table, and you also enable the load in QGIS when done. So you select this. Here you can see the error associated with your individual pixel point. So you can see the error is quite high. So I will change the transformation type or the sampling method. You have to shuffle. Now you can see with this transformation method Helmut and the resampling method nearest neighbor, so you can see your associated error is minimum. So I will choose this transformation and resampling method. So what is this what are the transformation method, and what type of method we have to use, and what are the resampling method? These all things I have explained in our georeferencing lab. So you can follow that lab, or you can understand about all this transformation method or resampling method and how it works. So once you selected your resampling or transformation method, you simply play the georeferencing tab, and now your georeferencing is started. So once you start is completed, you would see that one information you can see over here, and because we have enabled the load in georeferencing tab, so here you can see your map has been georeferenced. So you can now on the layer panel another map is added. You can see this is the name with the modified. So this is your georeference map, and the earlier image was this one, and here you can see there is one question mark symbol you can see over here. That means that this layer is not georeferenced, but the map which is named as the modified, here you can see this map is georeferenced. And once you put your cursor over this layer, you can see here your you can see the information regarding the reference system, that is the EPSG 4326. So this is the georeferencing code. If you want to understand about this coordinate reference system or the different kind of codes which are used throughout over the world, So if you are interested, so I will also give one lecture over the different kind of the geodetic or the local datum system or the UTM about the transfer Mercator projection system. So different kind of projections or the local datums are used throughout the world based on their own interest. So so that I can explain in one of in a separate lab. So here once you have georeference your map, so you can check your whether your georeference map is perfectly georeferenced or not, or whether it is associated some kind of error. So you can simply use your swiper tool. So this swiper tool will you simply drag your map over the base map. So here you can trace any of the features. For example, if I am tracing this river, so this you can see over here, this river is perfectly placed over the base map. So this I can say that it is associated with slight error, but for now if you want to accurate this map more precisely, you have to add more GCP's point with the help of your georeferencer. Here you can add more GCP's point, and that would ultimately enhance your map, and that would place your map perfectly over this base map. So that you can do, and once your map is perfectly georeferenced, so now you can use this map and you can identify different geomorphological features that you would be able to see in 3 dimension. So for that you have to use the 3D glass, and with the help of this 3D glass and this high resolution anaclyph, that is ultimately a DSM, digital surface model. So you would be able to identify the different geomorphological features, and you have to first thing is that you have to spend some time on this anaclyph, and once you have identified the different kind of geomorphological features based on your interest, what kind of features you want to add or trace, so that first you have to identify, and then you after you identified all those features, then you start your digitization, that is your mapping part. So now I would explain that how you can map all the georeferencing all the geomorphological features. So first use your 3D glass, and you analyze your anaclyph. So you can disable this base map, and now you can see. So here few things are that you can rotate your map if you are not able to visualize your map in 3 dimension. So you can simply rotate this map in 90 degree. So you can just simply type 90 and you click on enter. So here you can see now your map is now in this rotation. You would be able to see the different landform in 3 dimension. So now it would be easier for you to identify the different geomorphological features. So here you can simply identify the broader geomorphological feature, that is your river system. You can easily identify over here. The mountains are you would be able to identify simply. So now the geomorphological part, that is your river terraces, alluvial fan surfaces, or different kind of structural features, that could be your fault escarp that generated due to the faultings, or the nick point, or the sandbars, and the different kind of geomorphological features or tectonic feature that is associated with your different kind of faulting environment. If you see the deep slip environment, you would see the fault escarp, or you would see the your barping or pressure ridge. So this type of structure you would see that is basically associated with deep slip environment. And if you see the strike slip environment, you would see the offset of these streams, or somewhere where oblique displacement oblique displacement associated with the deep slip and the strike slip, you would be able to see the sack mounts, or your pressure ridge or this type of structure you would be identify with the help of this high resolution cartoset and the anaclif which you have prepared from the cartoset data, so that you can easily identify with the help of this kind of satellite data. So you based on your research interest, or you can identify those features, or you can trace. So here if you use your 3D glass, and you would see that here some kind of warping you can see over here in this place. So this here you can see where my cursor is, this area is at the downside, and this portion is at little bit up. So you can see this is some kind of this type of height perception you can see over this area. So these are basically the fault scarp. So this type of structures are basically forming due to the faulting when your hanging block is overriding on your football. So you would be see such type of structure. So these are basically associated with the faulting. So this you can trace on your map, or you can identify or you can trace this type of tectonic or geomorphological features. And the another kind of features you can see over here. So here you can see the level of steps on both side of your river. So this is your river, and here you can see this is a one level, and then another steps is here little bit high, and then another step is over here. So here you can see 3 level of steps. So these steps are basically your river terraces. So river terraces are basically when your river is changing its base level. It could be due to the tectonic, or it could associated with the climatic impact also. But whenever this is happening, the river is changing its base level. So that time the river surface is abundant, and it is formed abundant surface, and that abundant surface is called your river terraces. So these are basically the river terraces. So this type of these terraces you can map. So these terraces are basically giving you the idea about the different phase of climatic impact over this area, or it can also relate to the different phase of tectonic events. So whenever there would be any great tectonic event, that could be your great or large magnitude earthquake. So that time your river will change the base level, and it will form such type of steps, or it will form the terraces. So you can map these terraces, or to interpret the different phase of climatic or tectonic events. So you can also see the river deflection. So here in this area you can see that the one river was flowing from like this. So this is your channel path. So earlier this river was flowing like this. So this river was flowing straight, and then this area got uplifted, and due to this upliftment this river was not able to incise or erode this uplifted portion. So it changed its course. So now you can see this river is flowing from this area. So this due to this deflection of the river, so this area is now abundant, and this portion is called your bend gap. So bend gaps are those areas which are basically earlier it was part of the river channel, but now it's abundant, and the river is not flowing in this area. So this is called the bend gap. So such this is also a tectonic feature. So you can map this type of tectonic feature. Here you can see this is a basin type structure you can see over here, and this is called the sack pond. This is also associated with the strike slip faulting event, or strike slip faulting. So this all the tectonic as well as the geomorphological features you can identify with the help of this high resolution anaclif. And once you identify all these features, then you have to start the digitization part. So today we will stop here, and in our next lecture we will we will explain you that how we can start the digitization and how we can map the different tectono-geomorphological feature with the help of this QGIS and this anaglyph. So, thank you.